Good morning. My name is Ulrich Saldersrechts. Welcome to this next session of the Open Cloudification webinar series. This series started just over a year ago when we basically started off with the activities of Open Cloudification, which is a Flemish project that we are executing as LSEG together with ID Lab from University of Ghent and the Beacon. To promote basically the use of cloud native and open source cloud applications amongst companies, mainly in Flanders, but actually also throughout Belgium and the rest of Europe. The idea is that we want to make sure that at least companies who are developing these days understand that there are some alternative technologies and solutions available next to the public cloud providers. And that at least they would be able to consider those when they are developing their own applications and technologies. In the different series of webinars that we have been working on, we start off specifically on microservices and working towards serverless. But we've been dealing with many other different topics related to security, identity and access management, and definitely also quite a lot of edge components. Somewhere in between, in a number of cases, we've also dealt with the ongoing developments of the use of AI, and specifically MLOps and AIOps. Using AI components and technologies into a cloud environment, typically coming from the more analytical types of artificial intelligence. But these days, of course, with the recent evolutions since the beginning of the year of large language models and Gen AI, there's of course quite a lot of other opportunities that are appearing. And therefore today we have a specific topic on what in this case our presenter of today, Merlijn, has been developing in terms of title AI Openwashing. But he'll be talking a little bit more about that in a second. Before I hand it over to Merlijn, there's a couple of very small things I would like to announce. In the previous webinars, we have talked about some of our other activities in relation to supporting companies in making their transition towards more either digital environments through the Digitalis activities or towards more cybersecurity. Today, I would like to announce that we started on the 1st of June with a new activity. In this case, it's called KISD. And it's also part of this Digital Europe program, supporting actions, whereby Europe is specifically searching for capacity, capabilities of companies and people that could do things in relation to, for instance, pen testing. And so what we can offer here is to companies, research institutes, or other types of organizations, funds of up to 200,000 euros to actually do some analysis on potential vulnerabilities and on potentially also finding vulnerabilities in systems, which could be both cloud environments, applications, in this case containers or microservices, or related, or on the other hand, more related to edge devices or IoT devices. So basically all types of appliances or services that are being used on the internet, which could have cybersecurity challenges, can be used. And so the main objective is that you would be doing that specifically through participating to one of our open calls. There will be 2 open calls specifically for companies and research institutes. And we are looking for different types of methodologies and use cases, which then potentially also could lead to actual implementations. And that's also what we would be looking for. So if you already have some of those types of activities going, if you are doing pen testing activities or vulnerability assessments, potentially also with critical infrastructure companies, and also preferentially with SMEs in that space, then we are very much welcoming your application. The first open call will likely start in the fall period, so after the summertime. And so what you will be able to do is to simply drop us a note or an email and say that you have an interest, so we can send you the requirements once we have them available throughout, let's say, probably a September timeframe. And this way, you will be able to already see quite early on how you will be able to participate into these open calls. We'll be doing the open calls together with the different NCCs throughout Europe, throughout the different member states. So the NCCs being the National Cybersecurity Coordination Centers. And together with them, we also will be promoting these calls, obviously, into the market. So a couple of ideas, maybe, specifically in relation to what we do here within Open Cloudification. And that is, for instance, using maybe some of the existing offensive security tools and maybe further elaborating on them. We will be hosting, in this case, also an activity where we'll be going a little bit more in depth on these tools and showing how they can actually be applied and what they can actually bring. So it might also be for you an interesting way to consider to either use those mechanisms and those tools as a means to further investigate on cloud environments and maybe also specifically on open cloud environments. Or you could imagine developing some of these tools yourself, putting them into a GitHub environment and then using those. Or maybe as another mechanism, this one, canary token, being used to ensure that you can actually also find when malicious users are trying to hack into your systems or containers. So by putting in these small tokens, they can actually be spotted. So a couple of ideas for you to consider, maybe either applying them, using them, or maybe even further working them further out. So this is what we'll be doing under the KISD project. And so if you have an interest, then please do contact us. For the rest, the SME support is still there, both for Digitalis and also from KISME. So with this small promotional intervention, I hand it over with great pleasure to our colleague speaker, Marlijn here. Hello, good morning, Marlijn. How are you doing?
Good morning. Everything is great here. Let me share my screen.
Yes.
Can you see my screen?
Yes, we can.
Okay, great. And the text
is
is readable.
Yes, perfect.
Good morning, everybody. I'm going to talk about open source AI and the risks associated with the current wave of openwashing. If you read the news, then you might think that open source AI is winning because there's a lot of catchy headlines like Meta's new Llama 3 models give open source AI a boost, and Meta raises the bar with open source Llama 3 LLM. And even Meta themselves, talking about their Llama 3 model, even they themselves call it an open source large language model. So, okay, that's cool, open source. So let's look at what we are actually allowed to do with that large language model. And so if you go and look at the Llama license, then you suddenly see a lot of restrictions. For example, you must adhere to laws in order to use this model. But like having to adhere to laws, this is something quite complex, and in a sense it's quite useless to put this in a license agreement because it is illegal to do illegal things. You don't need to put in a contract that somebody is not allowed to do illegal things because it is illegal to do those things. And then secondly, like given that Meta is a US company, are they talking about US laws? Are they talking about the laws of the company that is using this open source model? This is quite weird and not common for open source software. Then secondly, they have like this very extensive acceptable use policy. This acceptable use policy is basically a list of things that Meta thinks is an acceptable way to use their product. So it's an additional list of things you are not allowed to do with this model. And some of these things are quite tame, like you're not allowed to use these models for discrimination, for example. But then there's also a lot of things that, depending on where you live, depending on your jurisdiction, there's very different views on this kind of use. For example, you cannot be a sex worker, even though sex work is completely legal in Belgium, and most Belgian companies the products of most Belgian companies will probably be used by sex workers in a legal fashion at some way or another. Um, you are not allowed to use Llama 3 if any of your customers are sex workers. Then you cannot use Llama 3 in order to improve other models. The only people who are allowed to use Llama 3 in order to build or improve other models is Meta themselves. Then Meta added like a certain clause to this license. You're not allowed to use this model if your active monthly user base is greater than 700 million. And so Meta thought, this is amazing. We can give our open source model away for free to everybody, but block Amazon and Google from using our model. But like clauses like these always have unintended consequences. For example, if you're a contractor for the Indian government, you're not allowed to use these models because the Indian government has more than 700 million monthly active users. These kind of clauses, they never do what the initial intention is. And that is why these kind of clauses are actually forbidden in open source software. So Meta, you keep using the word open source to refer to your large language model, but I don't think this means what you think it means. And I think that a lot of companies will be very surprised when they start to look at these licenses of how they are allowed to use this software in their product. In my opinion, open source is about democratizing technology, making technology available for all, regardless of whether you agree with what that person is doing or not. We are basically standing on the shoulders of giants. So if you think about why in this day and age is it so easy to build a cool Android app that does very cool functionality, why is it so much easier than 10, 20, 30 years ago? It's not because software developers have become so much smarter than 20, 30 years ago. No, it's simply because a very large part of building an application has actually already been done for you. Every single Android application is chock full of open source software. But to a lot of developers, they don't really see that because they're just interacting with libraries that then have dependencies on other libraries that have dependencies on other libraries. And because of that, because all this work built over the past 30 years, because all this work has been open source, we can simply use it to build new products. But this isn't only about like this kumbaya message of like we need to unite as a society. This has real implications on companies using open source. Companies have been confident that there are a lot of freedoms that open source software gives them that allow them to benefit commercially from that software. And it's the same with open source AI. Why are so many companies looking at open source AI? Llama is one of the most widely used AIs, even though it is open source. So the first big reason for this is cost. It can cost up to $230 million to train an AI. And if you want to use a pre-trained AI, if you look at ChatGPT, for example, that's quite expensive, especially if you just want to integrate it in your website or something. It can be quite expensive. So that's the first reason that companies are looking to open source to integrate AI into their product. Secondly, privacy. Are you able to run the AI locally and keep the data locally? In terms of GDPR, this is a great benefit if you're able to do this. Will your data be used for training? Because by default, If you use ChatGPT, everything you write in ChatGPT will be used to train the next version of OpenAI's business model, OpenAI's models. Um, then thirdly, what about risks? So we recently had VMware being bought by a different company, and they hiked their prices 10x. This is quite risky, especially if AI is a core part of your product. It can be quite risky to simply depend on another company's pricing model in order to be able to integrate that AI into your product, because the provider's strategy might not always align with your strategy. Maybe it aligns at this moment, but it might not align at some point in the future. Then also in terms of purpose, can you use the AI to compete with the provider of the AI? Large companies like Microsoft, like Meta, like Google, they basically are trying to capture the entire market, the entire IT software market. And so there's a lot of companies here in Belgium, here in Flanders, that in some form or another actually compete with these providers of these AI models. Like, will you be able to continue doing that if you're so dependent on their AI models? And then finally, functionality. Do
Hi,
you
hi,
need to
Vincent.
modify? Do you need to modify the AI for your product? And then this might seem like a lot of Flemish companies will answer no to this question. No, we don't need to modify the AI for our product. However, keep in mind that this might not be you as a company specifically, but it might simply be us as the European Union, for example. Because in the US, where a lot of these AIs are being created, you basically have a single language, English. And so these AIs are great at English. However, in the EU, we have, I don't know from by heart how many languages, but an incredibly large amount of languages in an incredibly small space, which means that all these AIs need to be able to translate and understand and talk in all these languages. I did a small test with ChatGPT, and I simply asked it in Dutch, is your knowledge of Dutch the same quality as your knowledge of English? And it started explaining, well, no, I have a lot less knowledge about the Dutch language as I have about the English language. And if you ask questions in Dutch, I will probably understand it, but I might not be able to answer everything. And so this, first of all, shows that we are at a disadvantage here in Europe because of our language diversity. But second of all, look at this. This is what happened when I asked that language. For some reason, ChatGPT marked my question as content that might violate their content policy. I looked through their content policy and there's nothing in there. But the reason why that is because Dutch is an anomaly. So a lot of these AI models, they start to do anomaly detection. If people do anomalous things with this AI, then it might mean that they're trying to hack the AI or trying to do something that's not allowed. And so then they report those things, then they report those queries. And simply because Dutch is such an uncommon language to be used, all this anomaly detection logic, it's much less useful and it makes a lot more errors in Dutch than in English. I also asked that question in English, and then it didn't tell me that my question violated their content policy, but simply because my question was asked in Dutch. And all the different parts of this AI know a lot less information about Dutch, including their anomaly detection, including their detection of violations, it saw my question as a violation of their content policy. So this can be quite risky because a lot of these very, very large companies, when they detect certain anomalous behavior, they will simply close down your account, and good luck trying to find a human to explain that you actually didn't do anything wrong. So this is why I'm giving this presentation, to shine light on the issue of AIs calling themselves open source, but not actually being open source. And in this presentation, I will answer 4 questions. First of all, why exactly is AI breaking open source? For a very long time, the entire industry had a rough consensus about what open source was and what open source wasn't. Why suddenly, now that AI is happening, why is there suddenly disagreement about what open source is? Second question I will answer is, what is being done to solve this problem? And where as a user can you find resources in order to figure out whether or not an AI is actually open source, regardless of the marketing material of the company building that AI? Then the third question is, what level of openness does your company actually need? Because open source AI, this label, this is basically a binary choice. Either an AI is open source or it's not open source. However, for you as a company, it can be very interesting to see the entire spectrum of openness. There are a lot of advantages to using a more open AI, even if it is not completely open source. And then finally, I will talk about which open and open source models can you actually use today. But then who am I? I try to put a cold open in a presentation. So instead of introducing myself at the start of the presentation, I do it now. My name is Merlin. I'm a senior researcher at IMEC. I work on software delivery to cloud and devices. I'm a lecturer at Ghent University. I teach a lot of courses such as systems design, open source ecosystem, and computer security. And I'm also an open source developer, both in the open source governance side of things. I'm part of the Ubuntu Community Council, the highest leadership body of the Ubuntu community. And on the development side, I'm working for Snapcrafters. I'm building WebAssembly system interfaces. So I have some experience with open source. So the first question is, why is AI breaking open source? But in order to answer that question, I actually have to first explain what open source software exactly is, just so we all get on the same page. So my explanation is a little bit more clear. So open source software is about sharing the design plans of software. This is probably what everybody understands about open source, but it's sharing those design plans using an open source license. And so a software license, is basically the end user license agreement. This is the major source of in the world. Everybody says when they install a piece of software, yes, I've read the license agreement. I accept the license agreement, even though they haven't. This is basically the software license. This describes how you can use the software. And some of these licenses are paid, like Microsoft Office. Some of these have a zero cost, like Fortnite, for example. And some of these licenses are open source, like VLC Media Player. So what makes a license open source? Well, the answer to that question is who. The Open Source Initiative defines what open source software is, and they define what an open source license is. It's a non-profit created at the end of the 90s. that defined open source software as software that's distributed under a license that allows the user to run the software for any purpose, see the complete source code of that software, modify the software, and share the software and the modifications under these same terms. This is based on the Debian Free Software Guidelines, which have been rewritten a little bit in order to make it the general open source definition. And so the open source initiative are globally basically the gatekeepers who decide what is open source software and what is not open source software. And interestingly, recently, they actually had a court case that legally affirmed that the open source definition created by the open source initiative is actually what open source software is. And if companies say that something is open source, but it doesn't adhere to this open source definition, then the court affirmed that that means that that company is doing false advertising. So unsurprisingly, the open source initiative immediately when Meta's Llama model was released, they said, created a blog post, Meta's Llama 2 license is not open source. But then Meta started complaining. They were like, oh yeah, but you see, we say that it's open source because this and that and that. And so why is it so complicated to figure out whether or not a certain AI is open source? Well, let's compare it with a regular software pipeline. And what needs to be open source in a regular software pipeline for the software to be open source. So in a regular software pipeline, first you have some build setup. For example, make uses build files in order to set up the compiling environment in order to build your software. The entire tool suite in order to make this compilation environment, that this doesn't have to be open source. The only thing that needs to be open source for your software to be open source are the build files themselves. So the thing that instructs the make tool chain in order to set everything up. Next, you have a compile step. You compile the source code into binary code. Here too, the compiler itself doesn't have to be open source. What needs to be open source is the source code itself, the source code of your software. This needs to be open source. And then finally, the binary of your software needs to be open source. Then you run your binary on the system. The system itself doesn't have to be open source, and the data that your software uses, it also doesn't have to be open source. And so initially, when the open source movement happened, there was some debate. Some people, for example, said, no, in order to have truly open source software, the compiler itself also needs to be open source. But as a community, the open source community basically agreed that no, the only things that need to be open source are the build files, the source code, and the binary. Even though you require a compiler and you require these make tool chains in order to build your software, you don't have to open source them. And one of the reasons why they made that decision was because at the time, open source compilers simply didn't exist, which meant that at the time, the requirements for open source software would have been so stringent that not a single piece of software would ever be able to be open source. And so then what's the use of this term? Because if nothing can be open source and we try to build an open source compiler, but nothing can be open source, then how can we get from a situation where nothing is open source to a situation where everything is open source if everything needs to be open source? They basically decided that, look, only the software source code needs to be open source, and creating open source compilers is a different problem that we will solve separately. At this point in time, the most popular compilers are also open source. So this is less of a problem at this day and age. But I want you to remember that when open source software, the idea of open source software was first created, a lot of discussions happened about what components need to be open source. So then let's compare it with a software pipeline for an AI system. And if you're thinking, hey, Merlijn, this image is way, way better than this image, well, there is a reason for that. This is the image that I created. This is the image that my partner helped me create, who is really amazing at creating visualizations. So this is the build pipeline for an AI software. The first step is the main training step. The main training step takes model code as input, input data, and training code. And the end result is a foundational model. Then you have a fine-tuning step, which is basically a circular process where you use fine-tuning code and fine-tuning data in order to create a fine-tuned model. And then that model, you take it through a next step of fine-tuning with new fine-tuning code, new fine-tuning data, and you can have like 5, 6, 7, or maybe 10 steps of fine-tuning the model in this cycle. And then the last step is actually running the model. In order to run the model, you first need the model itself. You need the inference code. So for an AI, the inference code, you can see it as the runtime. The inference code is like the Python runtime, and the model is like the Python code itself. And you also need prompts, who sometimes come from the application developer or who sometimes come from the end user. And that's the end result. That's what the user then interacts with. And a lot of these models, they then take a lot of the user input, use it as data for another fine-tuning step, fine-tune the model again, release the new model, and then use that for users again. So this is really a cyclical process that keeps improving the model. And so here you obviously have some complicated questions about which components in this pipeline need to be open source for the AI itself to be open source. And so basically, what Meta is saying with Llama is that the only thing that needs to be open source in order to be able to call the AI open source is the inference code. The model itself is not open source. Their prompts not open source. Their data, their training code, their model code, the initial training code, it's all not open source. The only thing that's open source in Llama 3 is this inference code. And Meta is saying, because this inference code is open source, we can call the entire AI open source. But again, the inference code, this is not the actual AI that is running. The inference code is simply the runtime in which this model is running. For example, the inference code between Llama 2 and Llama 3 is almost exactly the same. Because the main difference between Llama 2 and Llama 3 is that it's a completely new model which was trained in a completely different way. And so obviously, there's a lot of complexities here about what is open source. And this is even a simplified example of the build pipeline. If we look at Llama 2, this is the image that Meta themselves showed of the Llama 2 build pipeline. This is even more complicated than what I had on the last slide. So to answer, why is AI breaking open source? Because it's unclear what parts of an AI system need to be open source. There is no definition of the term open source AI. There is very little precedent about what specific components need to be open source. And then additionally, models, AI models themselves, are almost a mix between code and data. And so in order to solve this problem, the open source initiative is creating the open source AI definition. This is a global effort where they're pulling in as much stakeholders as possible in order to create a a rough consensus around a definition of what open source AI is. And so the first step started late or mid 2023 was describe the problem and collect ideas. So they did an open call for papers and presentations about what are the specific problems of open source AI. Why is this breaking the open source software definition? And what can we do to solve this? There were a lot of people involved in this process and who still are. People who are creating AI systems, people who are creating AI licenses, governments and regulators, licensees, so the people wanting to use and study the AI, the end users who are actually using the products that are enhanced with AI, and the specific subjects, both people whose data has been used to train these AI and people who are interacting with AI systems, even if they don't really know it. So the next step in this process was to draft and review a first initial definition of what is open source AI. And in October last year, they created a release candidate one of the open source AI definition. So what is the open source AI definition? I'm going to quickly go through it through the current draft, which is version 0.0.8, which was released last month, I think. First of all, the open source definition starts by explaining that it doesn't say how to develop and deploy an AI system that is ethical or responsible. This is not a document that takes the norms and values of a certain country or a certain population and then says that only if AI systems adhere to these norms, then it is ethical AI. No, this definition only says what open source AI is. And you can have ethical open source AI and you can have unethical open source AI. Whether or not an AI system is ethical is just a completely separate discussion. This is only about a definition that if an AI meets this definition, then everybody can use it for free, can modify it, and can integrate it in their products. This says nothing about ethicalness. Next is the actual open source AI definition, which is very similar to the definition of open source software. An open source AI is an AI system made available under license terms that grant the freedom to use the system for any purpose without having to ask for permission, study how the system works and inspect its components, modify the system for any purpose, including to change its output, and share the system for others to use with or without modifications for any purpose. And so that seems quite logical, doesn't differ much from the open source software definition. But then the last part is what is so important for this definition. Preconditions to exercise these freedoms is to have access to the preferred form to make modifications to the system. So all the components that are needed to make modifications to the system need to be released under this open source license. And then they go on explaining what the preferred form is. And this is the most important part of this definition. This includes data information. This is a description of the training data. It doesn't have to be the training data set itself. It only needs to be a description of the training data. This includes how you trained it, how you selected data, how you labeled the data, where the data comes from, what the characteristics are, and more things like that. The second thing that needs to be open source is the source code, both the source code used to train the system and the source code used to run the system. So train is the training source code during all these training steps, and then running the source code for running the system. This is what we call the inference code. And then thirdly, what also needs to be released under an open source license are the model parameters. That's the AI model itself, including, not required, but optionally, including checkpoints from key intermediate training stages and the final optimizer state. So then they created a very long checklist of all the different parts of the AI system, and basically an explanation of what kind of license they need to be released under. So then the first question that people often have about this definition is, why don't you require the data sets, the training data cells themselves, to be open source themselves? Well, the first explanation is that in order to modify an AI system, you don't really need the original training data. You only need training data that is similar and that is of high quality in order to be able to modify it. Even if that data is not the exact same training data that the company initially used, you can still completely retrain the model and have a model with similar performance. Because these data sets are so large, it doesn't really matter specifically even each and every word that is in that data set. The thing that matters mostly is how big it is, what is the quality of the data set, what language is the data set in, what type of data is used there. Even if it's not identical data, you will still get very similar performance. So in order to be able to change an AI system, we don't actually need the data to be open source. So it's not part of the open source AI definition. Secondly, there's a lot of legal uncertainty about training data sets. Currently, there's a lot of court cases that are running that are trying to set precedent for all the legal ramifications of AI training data. And as a result, a lot of companies building AI systems are not able to share the training data that they use, even if they want to. For example, it could be because of privacy issues. It could be because of licensing issues. There's a lot of companies like OpenAI that are saying, and some some legal professionals are agreeing with them, but what they're basically saying is that we can train an AI on closed source data, and the result, that AI model, that resulting model is not adherent to the licenses of the training data. And so even if they want to open source the AI model, they cannot open source the training data because they don't actually have a license for the training data. And then finally, a lot of these AI models are trained on data that even the company building the AI model does not have access to. For example, almost every user of an Android smartphone uses Gboard, the Google keyboard, in order to type. This keyboard has predictive functionality in order to be able to write quicker. This predictive functionality, this is trained using federated learning. This is constantly monitoring your keystrokes and then locally on your smartphone training a tiny AI model in order to be able to better predict that data. And then the resulting AI model is sent to Google. But all the data that is on your smartphone, all the data about your keystrokes, those are simply not sent to Google. So even if Google wanted to open source the data of their Google keyboard AI, they couldn't because they don't have access to the data. This is great in terms of GDPR, but this also shows that it would be problematic if these kind of federated models, which are even more privacy preserving, could never be open source because the data would have to be open source. That's another reason why the open source AI definition doesn't require that the original data set is open source. And then finally, there's the question of pragmatism. It is currently impossible for even the largest AI producers to open source their training data set because they simply don't have licenses in order to use the data themselves. Um, Secondly, open data requires a completely different approach in order to create open data sets than open source software. It's a completely different field of law, of licenses, and it's a completely different field of communities that are pushing in order to get open data versus communities that are pushing in order to get open source software. And there is a requirement, there will need to be we will need a lot of legal and policy changes in order to actually create truly open source AI training data sets. And then I wanted to quickly show the similarity with proprietary compilers. When the open source software definition was created, they specifically excluded compilers from the requirement of open source software, also for a lot of pragmatic reasons. So what is currently happening? Currently, the open source initiative is validating the open source definition and the open source definition checklist in order to see whether or not this open source definition really adheres to what people think open source AI should be. This is something that everybody can get involved. I am currently validating a certain model that claims to be open source. I'm currently validating whether that model is actually open source using the open source AI checklist. If you're interested in helping this effort, go to that URL, opensource.com/deep dive, and you can get involved in creating this definition and validating it. But then let's get back to, this was a lot of theory, let's get back to more practical stuff. What level of openness does your company actually need? Open source AI should not be the only metric that you use in order to evaluate whether or not this AI is useful to your company. The term itself is very useful, and it's important that we have a set definition. The binary nature of the definition has its limitations. So either something is open source AI or something is not open source AI. There's no gradient in that. It's just binary. But there is a lot of value in models that are more open than ChatGPT, for example, even if they're not yet completely open source. Moreover, not all AIs that are open source are actually created equal. Even within the open source AI models, you also have different gradients. If you only care about this label of open source AI, I put the results of the current evaluation here in a screenshot. So it's basically this takes a look at whether these AI systems meet the open source AI definition requirements. And the evaluation says that the Arctic models, the Olmo models, and the T5 models will probably be seen as open source AI. The Bloom models, Llama 2 and Mistral, will probably be seen as not open source AI. But as a company, there's a lot more to take a look at. This is why I created this open source AI openness scale. So it starts from completely closed systems like ChatGPT up to completely open source systems like the Viking and the Portal models. And it basically depends on which specific components of the AI pipeline are open source. So if you look at Llama and Gemma, Llama is the model from Meta, Gemma is the model from Google. They are basically in the use for free category. These are models that you are allowed to use without paying the producer of the AI model, but there are a lot of restrictions on how you are allowed to use the model. Moreover, the only thing that these companies release is, first of all, the open source inference code, so the runtime of the AI model, and secondly, the model itself. and the model itself is opened using a use restricting license, for example, the Meta Llama license. However, you are not allowed to use it for any purpose. The second category of models are models that allow you to use the model freely for any purpose. Any purpose you want to use, there are no restrictions on it. These are models that open the same kind of things, both the inference and the model itself, but they are both opened as open source, using an open source license that allows you to use it for any purpose, instead of the use restricting license. Then thirdly, you have the licenses, the AIs that allow you to fine tune and use the model freely for any purpose. This means that not only is the inference code open source and the model, but also the training code. And the training code is what is necessary for you to actually confidently fine tune these models freely. And so a few examples of these models are Mistral, Mixtral, and OpenChat. I think OpenChat is a sort of ChatGPT-like model that is based on Mixtral, I think. And so these models allow you to embed these AIs into your product, use them for any purpose. And if you want to fine tune these models for your specific use cases, if you want to feed knowledge in them from your databases, for example, you're able to do that for any purpose. Then we come to the truly open source models. Truly open source models allow you to completely retrain the model from scratch, from zero. And they do this by also having an open source description of the training data. This is critical. This is one of the reasons why the Mistral and the Mixtral models, they cannot actually be used by researchers in order to improve, for example, AI performance on very specific European languages. They cannot use the Mistral and the Mixtral models simply because we have no idea what the training data is. And so for that reason, it's very, very hard to actually simulate to simulate the training of Mistral, but then with other language text included in order to see what the performance then is on other languages. But open source models allow us to do this. Examples of this are the Arctic models, the Olmo models, and the T5 models. And then finally, there is another step. Even if an open source, even if a model is open source, there's one more step in the openness scale, and that is to be able to retrain the models economically without having to expend massive amounts of capital on GPUs and on energy. And they do this by open sourcing intermediate models, checkpoints from key intermediate stages in the learning pipeline of the AI system, and by giving you the training data itself, also available as open source data. So I want to zoom in a little bit on this last category. Why do we care so much about these checkpoints of the intermediate training stages? This is very, very important if you actually want to significantly improve the performance of an AI system, because AI training costs are incomprehensibly large. For example, Google's Gemini Ultra model took almost $200 million in order to train the foundational model. This is the kind of capital that is unavailable to almost every single Flemish company, to almost every single Belgian company. As a result, even if Gemini Ultra would be open source, it will still be impossible for Belgian, Flemish companies in order to actually start to retrain Gemini Ultra in order to better adapt to their use cases, because they simply don't have the capital in order to retrain them. And there's a lot of reasons why you would want to retrain that. For example, you want to add or remove languages before fine-tuning. You want to remove certain data from the training data. You want to use different training techniques. For example, to use adversarial training in order to make your AI more robust against hackers, or to reduce the not safe for work and toxicity that your models might produce, or in order to compare training techniques in intermediate phases. If you don't have any checkpoints, every single time when you want to compare the result of your AI to the Gemini Ultra model itself, you need to expend another $200 million in order to do all the steps in the training stages in order to get to the end result. However, if we have intermediate checkpoints of such a model, then we can simply go back to the checkpoint where a certain language was added or removed, and we can build from that point on, and we can immediately test it with the next checkpoint of the other model in order to see if our changes actually improved things or not. And if you're still not convinced about how important these checkpoints are, just ask Google, OpenAI, and Meta if they're keeping these checkpoints internally and how much they're using these checkpoints internally. And the answer is yes, they are obviously keeping every single checkpoint of every single model they ever trained, and they are using it constantly in order to improve these models. It is completely possible to do all these things without checkpoints, but it will be prohibitively expensive. And so another way of looking at these checkpoints is if you just look at how much training data and how much training effort is needed in the different stages of the AI. So this initial pre-training step, the main training of the AI, is using data in the order of hundreds of billions to trillions of tokens. While all these instruction fine-tuning steps, they only have thousands to 10,000 tokens. So if you have intermediate checkpoints between this step and this step, then you can very easily skip this incredibly expensive training with trillions of tokens, and you only have to redo the training with thousands of or tens of thousands of tokens. This is why these checkpoints are so important, because they will save you a lot of money when you want to start modifying these AI models. If you want to figure out, okay, I have this AI model, I have this ChatGPT alternative, how open source is it? The best resource at the moment is the website openingupchatgpt.github.io. This has a very, very long table, a complete list of all the different ChatGPT alternatives, and explains how open source all these alternatives are. This is based on a research paper by a bunch of researchers that took a deep dive into all of these different models. It is currently being updated. However, with the speed of the AI landscape, it's not clear whether in a year or two this will still be the main resource. So some concrete tips. Which specific models can you use as a company? Which specific models can you use? And how can you find these models? So there's some important considerations. I want to give a little bit, the bit of disclaimers to the information that I'm going to give you now. First of all, this is an incredibly fast-moving field. There are constantly new and upcoming players. There are many, many different benchmarks in order to see how good an AI model is. And there's many, many different tasks that an AI model can do. A few tips. Always verify and test the model for your use case. you can use the official benchmarks as like an idea of, is this an AI model that's worth looking into, or is it not worth looking into? But always compare the top contenders for your specific use case, because depending on the use case, some of the AI models might be better than others, even if they appear worse in benchmarks. Second of all, keep an eye out for new entrants, both new models from existing players and new models from new players. For example, here in Europe, there's a lot of EU funding now going to some of the top AI research groups in Europe in order to build some truly open source AI models. Keep an eye out for this field to see whether or not a better AI model appears. But then, the model specifically. The best, or according to most benchmarks, the best model that allows you to fine-tune and use the model freely for any purpose is Mixtral. Mixtral is an AI model from the French startup Mistral. It is competitive with the Llama models, but it has no restrictions on how you can use the model. So it is, in most benchmarks, it is the best model in the category of models that you are allowed to use freely, that you can integrate into your products, and where you don't have to worry about any licensing terms being risky to your business. However, the downside of the Mixtral model is that there's no information about the training data set. And as a result, it's quite difficult in order to really truly modify the AI model itself. You can still fine-tune the model because a lot of the training code is open source, but you cannot use Mixtral, for example, in order to create truly foundational models that cover every single European language. Then, in the truly open source category, and I put an asterisk here because, like, the open source definition has not been released. A lot of this evaluation of these AI models have not been completed, but it seems as if these models, once the definition is released, once the evaluation completes, it seems as if these models will be labeled as truly open source. These are some of the most interesting models in the open source sphere. First of all, the Arctic models from Snowflake. They have better performance for certain specific tasks like SQL. However, often what Snowflake is doing, for example, is that they're combining their own Arctic models with the Mixtral model in order to have a really, really interesting and very competitive performance. Then secondly, you have the Olmo model. The Olmo model is a completely open source model, which has the closest performance to Mixtral. But it is very clear which dataset it uses, and the entire dataset itself is also actually open source. And so Olmo is a great model for researchers and for companies who have a research track where they want to truly improve foundational AI models. Then you have the Viking and the Poro models. These currently are, you can see them more as preview models. I wouldn't currently really put them into any products, but they really show the great potential for European-built models that are specific to European languages. These are built by a collaboration between a very large Nordic AI research group and I think it's a Turkish university. Completely open source models that are very rapidly evolving to include many of the European languages and that show a superior performance in European languages. This is basically some of the things I can recommend to you today, but I have to add the caveat: this is a field that is evolving very quickly, so this information might be out of date quickly. So I also want to give you some tips for searching, because the best thing in such a field is to often search for the best models. So the first thing you can do is check the openness at opening up chatgpt.github.io. Um, Most of the models themselves are released and have metadata and information about them at Hugging Face. HuggingFace.co is basically a repository for some of the best open models. It's also a great resource to really figure out what the model license is. For example, for Llama, if you go to the Hugging Face page for Llama, you can immediately see a big disclaimer that says that it's not an open source model, even though that page is also written by Meta themselves. They make it very clear at Hugging Face that it has a specific license, even though in their own marketing material on their own websites, it's very hard to figure out what the actual license is. Um, Hugging Face also has a couple of leaderboards. The main one is the OpenLLM leaderboard. The OpenLLM leaderboard at Hugging Face basically compares all the different open LLM models and sees which ones have the best performance. And there's also more specific leaderboards. These slides will be shared after this presentation. These slides will be shared, and these are clickable links. But they also have some more specific leaderboards for specific tasks like generating SQL queries or generating certain code in certain programming languages. Also very, very important to take care of is beware of Llama derivatives. There are a lot of people on Hugging Face who take the Llama model that is not open source, change a little bit of the model weights, and then put it back on Hugging Face and then say, this is a new open source AI model. Anyone can use it for any purpose. This is not how open source AI works. Obviously, if you take the Llama model and you change it, then the changes are still have to adhere to the Llama license itself, even though the creators of these models claim that they are open source and that you can use them for any purpose. You cannot use them for any purpose. You still have to adhere to the Llama license. Really inspect the model card and the creator well when you choose a certain model to ensure that it's not a Llama derivative, that it is an original model or a model derived from other truly open source models. And then finally, just keep testing. For your specific use case and your specific product, even though these leaderboards give some idea of which models are the best, for your specific use case, other models might be better. Then I also wanted to talk a little bit about the road ahead. Verification, compliance, and transparency for open AI models and for AI models in general. Because even if the open source AI definition gets released, we still have the issue that it's quite complicated and quite complex in order to actually figure out whether a model is open source. And that is why in our research group, we are currently working on creating AI bills of materials. So it's basically a signed metadata document that is describing the entire AI supply chain. Which code was used, where was it trained, which data was it trained on, which adversarial training did you use, which security policies did you include in the AI models. And while an AI bill of materials already exists, what we're currently doing is attaching that to remote attestation and trusted computing in order to truly have a signed bill of materials where you know that you can trust what the bill of materials says. Because at the moment, a lot of these software bills of materials and AI bills of materials, you basically have to trust the creator of the AI model, that what they say in the bill of materials, that's truly what's in the AI model. While using trusted computing, and remote attestation, we might be able to build a system where it is very, very difficult in order to actually forge these bills of materials. So what can you do? I have a few key takeaways. First of all, if there's one thing I want you to remember from this presentation, is that Llama is not an open source AI. When you're using Llama in your company, in your product, get a lawyer or get somebody with a legal background to read through the entire Llama license in order to figure out what the risks are for your company from using Llama. There is an open source AI definition, and if an AI model adheres to this open source AI definition, then you basically have a lot more trust and a lot less risk in using these AI models. And if you want to figure out whether certain ChatGPT variants are open source, just take a look at opening up chatgpt.github.io. Secondly, find the level of openness that you require. Take a look at the diagram on slide 49 to see what your company actually needs in terms of openness, and so which models fit that profile. And then finally, if you're interested, you can get involved in building this open source AI policy by going to opensource.org/deep-dive. We really need more people and more companies to build open source AI training data sets. And we need more companies to create, modify, and improve these open source AI systems. Finally, I also wanted to add a little bit about where does this webinar come from, Open Cloudification. As Ulrich said in the beginning, Open Cloudification is basically a project funded by Flanders Innovation and Entrepreneurship. They pay us so that we can help you. We help you adopt open source and cloud technologies and help evolve your cloud native journey. We can also help you deliver software to clouds and deliver software to edge devices. Very practically, what can we do? So we're doing these webinars. We also doing workshops, a few workshops every year, which are free for everyone to join. Then if you are a Flemish company, we can also go one level further and we can do one-on-one sessions where we can help you solve some of your problems in your cloud and open cloud journey. We also have experience sharing events with a large user group where you can learn from other companies how to use cloud technologies, how to deliver software to edge devices. And we have a completely free Kubernetes testbed that you can use in order to start experimenting with open cloud technologies. So thank you. Maybe I just want to say there are more events coming in the future. In August, we have a webinar about trusting edge devices with remote attestation. In September, we will have a workshop, Feather Quick Start Tutorial. Feather is a Kubernetes compatible system that is specifically built to deliver software to very low resource devices that are physically located far away from your data centers.
And in July, we also still have a webinar, Merlin. It's posted also on Open Cloudification. So if you're already registered for one of the Zoom calls or the webinars, then you normally invite also you're also receiving the invites for the upcoming ones. So the next one will be, in this case, on the 10th of July. And we'll be doing both key management in the clouds and partially FinOps. Some of the things that we actually postponed from earlier discussions. And as I said, probably also in September timeframe, next to yours will be working specifically on something more of fantastic capabilities in cloud environments. So other interesting topics, at least for people to follow up on. Belen, leaves me only to thank you for your contribution, as usual. Very insightful, very interesting, and definitely also for those people who are looking towards integrating AI models. I think it was probably an eye-opener. We'll probably also pick up on this conversation later on with some specific updates on how to do security for AI models or cloud-based AI modeling on the basis of MLOps or AIOps or something of a kind. So we have some specific results from some analysis and studies that we have been participating into, where we can definitely see that in many cases security is simply not being adhered in a proper way when it comes to trying to integrate AI components. So definitely not in terms of privileged access, definitely not in terms of data classification. And so you have many data models out there which are not even consented by the users, but are using personal data as a basis to do analysis. Or the combinations of LLMs with your own Gen AI environments, other interesting things to discover. But that's for in a couple of months. And in the meantime, if you might already have passed on the holiday period during the course that we have our next webinars, we wish everybody happy holidays, and looking forward then to see you coming back on either the recorded sessions or the next live session. Thank you very much.
Bye.
Bye.